jump in. Thank you everyone for joining us today. Team here at Platform 9, we've got hopefully a good session to cover off in our Ask Us Anything for March 12th. My name is Chris Jones. I'm a product manager here at Platform 9. I'm going to help run this session along with a few other people that we'll introduce in just a moment. We've got a few different ways to engage with us today. I believe you should be able to raise your hand in Zoom, and I think we can actually unmute you if you want to speak and ask a question, which I think would be awesome. There's also a Slack channel that's dedicated to our AMA sessions that has the history from previous ones, as well as any questions that come up today. We have someone dedicated to watching and making sure we respond to those questions as well. So that is another way. And of course, you can always use the Zoom chat if you like as well. We'll be watching that throughout the session. Anytime we do sort of demos or product-led stuff today, we'll be using the Platform 9 managed Kubernetes product, which is a SaaS control plane for orchestrating your cloud, edge, and private data center Kubernetes clusters. If you don't have an account, that's fine. If you have Kubernetes running anywhere, that's good. All questions are open and welcome. Today, some of the things, if there's no questions off the bat, we're going to have a bit of a chat and a look at storage, which is one of those necessary pieces of technology that kind of needs to be running for Kubernetes applications today, especially with enterprise applications that are stateful. So we can have a quick look at that as well. But want to make sure that everyone's aware we're here to answer your questions. So as much as we have a theme to talk to, any questions are welcome. So who's on the line today? There is myself, Chris Jones, product manager here at Platform 9. I'm coming up on 2 years with the company, looking after the Kubernetes platform. Prior to that, I lived in the application performance management world. I was at Quest Software and I product managed an APM platform called Foglight, as well as a software-defined secondary storage platform called CoreStore. So got a bit of a broad background and experience, and happy to chat really about anything that is impacting you in your adoption of Kubernetes. I'll let Raghu introduce himself. He's also on the line.
Hey everyone, I'm Raghavendra, and I'm distributed system engineer in Platform 9. And I too have been part of the Platform 9 family for the past 2 years. And previous to that, I used to work in a field of application lifecycle management and cluster lifecycle management in Kubernetes. So overall, I have 5+ years of experience in Kubernetes cluster lifecycle management and the applications that go along with it. So yeah, that's the introduction from me, so short and sweet.
Excellent. All right, I'm just going to jump straight in. I'm going to click stop share momentarily, and I can see a question from Oleski around Ubuntu 20. Bear with me 1 second as I share my screen entirely, which sometimes can be dangerous. Let's hope that none of my friends send anything strange on a chat that doesn't get blocked by, do not disturb. That could be embarrassing. All right, share screen, full screen, escape. There was a question that came in about Ubuntu 20. We did say in the release notes of 5.0 that was available in early access. There's been a few bugs we've found and identified, and we've actually fixed those in our 5.1 release. I've been working on that actually last night. This is a single node cluster running Ubuntu 20 on our 5.1 release, which will be coming out in the next sort of 7 to 10 days, we hope. So that will be up and working fully. Still in early access as we build out support across AWS and Azure as well. But Ubuntu 20 will be becoming available and working in that release. So unfortunately, you'll have to hold off onto then. 5.1 release also has some other cool features coming along that I can show off. See, I'm here. You'll notice there's a small change to add clusters. We're actually adding the ability to import clusters, which is fun. And that will be starting off with EKS clusters. So anyone that's running existing EKS workloads will be able to click import cluster and, add a cloud provider for Platform 9, come along, and then through all of your AWS regions, actually select them, select a cluster, and bring them in. So this is just loading in the background. We're also, as you'll see here, you can just choose the clusters, click next, and that will load in. Yes, there's some oddities going on here. This is a development platform, so always fun things that go along before a product is made GA. We're also debuting our application catalog running in the SaaS control plane. So that'll enable you to use public and private Helm repositories to deploy apps across all of our clusters, across EKS, and help, I guess, drive adoption into your Kubernetes platform as well. All right. Do we have any other questions that have come in so far, or should we jump into a storage-focused session? Nothing in Slack?
Nothing else at the moment, Chris.
All righty. Once again, if you want to just ask a question live, you can raise a hand in Zoom. We can track that as well. All right. So I'm logging into my platform here. So, Raghu, I mean, with storage, I think a lot of people sort of looked at Kubernetes in the early days and said, it's not required. It's all stateless, right?
Mm-hmm. Yep.
I think, I've seen over the past few years as enterprises have started to adopt Kubernetes, they've definitely all said, well, wait a second, we need storage, right? Our applications that we're containerizing leverage databases. Databases have persistency by design. So all of a sudden you can containerize an app, and then you have to solve this next level infrastructure problem, right?
Yeah, precisely. It was started as a platform for stateless applications, but people started moving their stateful applications as well. And with it came the databases backing the backend servers, which were used for the source of truth, and they needed a reliable storage behind the scene. And that is when storage came to the scene of Kubernetes, and people started thinking about it seriously. And now it has spun off into its own project with the help of CSI drivers. And currently it is booming with a lot of storage providers.
Indeed, it is. The CSI ecosystem has really taken off. For people unfamiliar with the CSI driver, maybe we'll start there. Originally with Kubernetes, all the drivers were what they called in tree, right, Raghu? And that meant vendors had to test with a release and validate that release, and then they had to wait 3 months if there was a problem that was found that was core to Kubernetes.
Mm-hmm. Yeah.
And the CSI project, the SIG, is working to provide a standard interface, just like the CNI project. It is providing a standard set of APIs and ways of interacting with Kubernetes to provide storage. The public clouds are a great example. Today, if you're running in a public cloud, that's either using a service, or if you're using something like Platform 9 to build a cluster, you can provision a storage class into that cluster, and it can natively talk to, say, AWS or Azure, and it will actually go and provision out block storage for you. That's using what they call the in-tree drivers. That's actually being taken away. All the cloud providers today now have CSI drivers, and I believe it's as of 122 that the ability to use a storage class to deploy a volume or any type of persistent storage in clouds will actually be taken away, and everything will be done via CSI drivers. So if you're looking at storage as a problem to solve, CSI is definitely the right way to get started. There are other methods but the way the community is trending, the way that all of the hardware vendors are trending is definitely to do CSI drivers. Just to show you how easy it is to find them, CSI drivers, Kubernetes, and you can see here I come here quite often. You'll get a full list of all these drivers, and some of them are open source, some of them are for say Dell, EMC, IBM. This is really a great place to get started. When you drill into one of these, they will actually provide you with instructions to get started and information around like prerequisite and stuff like that. I picked a poor one to drill into. Pure storage. Here we go. This will tell you about which versions are supported, any prerequisites that need to be completed as well. So it's definitely the right place to start with a storage question. I can see a few questions have come in. Let's see. All right. Leslie, I believe. Apologies if I enunciate names incorrectly. Coming from Australia, sometimes I haven't seen a lot of different ways of spelling names or enunciating names. If I remember correctly, it gave a 14-day test period. Do you think 90 days is better? Yeah, so if you sign up for our free tier, right now, if you have a cluster, we'll keep that running forever. If there's no clusters, we have about a 21 to 28 day grace period before we'll delete that account. We are actively working on the ability to sleep an account. So then if you have no clusters running, and you come back 3 months later, it'll actually just revive your instance and bring it back to life. It's all built and runs in Kubernetes. That's our SaaS control plane is a containerized app. So we are working on a way that if you don't have a cluster or if you're using VMs on your laptop, which means you're deleting them every time, it'll sleep. So hopefully that is live sort of in the next 4 to 6 weeks. Another question from Swetha. Should we use Kubernetes operators for stateful applications? Are there any advantages of using a Kubernetes operator? And how does it relate to making the application cloud native? Raghu, I might hand that one over to you. That's a great question.
Yes. Yeah, definitely. I mean, that's a genuine concern, like what Kubernetes operators are and what stateful applications are and whether they are compatible or not. So operators in general are a way in which someone can orchestrate their applications on Kubernetes cluster. So let's say you want to manage a deployment or you want to manage a stateful set. Your application can either be running as a deployment or a stateful set. So if you want to monitor the application, you want to manage the lifecycle of those applications, you want to take actions based on certain events. For example, if one of the replica sets goes down or some other event happens in the cluster and you want to take corrective actions or update the state of the application, you need operators. So operators can act as a blanket lifecycle management platform for any kind of application that you want to run. Depending on whether you should use it for stateful set application or just for stateless application, well, it depends. The stateful applications have their own set of problems that they need to deal with, and the stateless application has a separate set of problems. With stateful sets, you need a certain amount of certainty around applications going up or down. So let's say you have a Cassandra cluster and there are nodes in Cassandra cluster which are registered inside the cluster with a certain name. Now, if a certain application goes down, a certain replica set goes down and a new one is created in its place, you want it to be joining the cluster with the same name. So the stateful set construct helps in doing that. And you also make use of the lifecycle hooks of the pods, using which you can do a graceful termination of the pod and make sure that the state that is associated with that particular pod is properly cleaned up. And with the help of that, I mean, these are the things that you look for when you are designing a stateful application. And in stateless application, you do not worry about these things. So regardless of whether you are using stateful or stateless application, you can use Kubernetes operator in both cases. Kubernetes operator solves a different set of problems, and stateful and stateless applications have more to do with the kind of the application that you're dealing with. So yeah, that's my 2 cents on this. I hope I covered all the questions here. Chris?
Yeah, we use operators internally, right, within our platform. So our monitoring deployment that we deploy that pulls in the data here on monitoring, that's using an operator to keep the Grafana, Prometheus, and Alert Manager applications running. Correct?
Yep, that's correct.
And that's one of the benefits of operators, right? It has a known application state, right?
That is correct. So it closely monitors the application. The monitoring logic is designed to suit your application and to react to different instances, specifically for your applications only. You can design generic operators, but it is always good to have operators specific to the kind of applications that you manage, which in our case, the operator that manages the lifecycle of monitoring related pods is only doing that. It is not managing lifecycle of any other services on the cluster.
Yeah, so I think in terms of the question and how does it relate to making the application cloud native, I'd say cloud native is more about architecting the application to take advantage of some of the primitives or the base constructs in Kubernetes, right? Being able to use replica stats, having things being stateful or stateless, designing to interact with other containerized applications that might be part of that architecture. Operators are kind of a higher level construct. They really can help with resiliency as well. And where we find them really useful and where a lot of our customers find them useful is when you're running applications that are what I call kind of term as a Kubernetes infrastructure application. Prometheus, Grafana, Alert Manager is one of those types of applications. Fluentd, Ingress Controller. You build a Kubernetes cluster and you want these next apps, right? Because they're kind of related to the infrastructure. Without them, it's hard to do anything, right? We focus on using operators on those to make it easy for you to just consume Kubernetes and use it. So if you're building out, say, a data center, or you're building out Kubernetes clusters or re-architecting applications, and you're using open source products, finding ones that have operators and seeing how that can help improve your resiliency in your app would be a great place to start as well. Hopefully that helps. Next question here. Is there a CLI access to Platform 9 Kubernetes? Do you offer a CLI for automation? We do. We have some changes coming to the API access page that will hopefully make this a little bit clearer. What I will pull up though is docs.platform9.com. We recently just released a brand new CLI for our product. Rewrote the whole thing in Go to make it super quick and easy to get access to. So that's one way. I don't have a VM running that to show it, but it's in the UI if you want to grab it today. Infrastructure, nodes, onboard a node. Just run this bash command on any Ubuntu or CentOS node that you want to attach to Platform 9. Configure it to connect to your SaaS management plane, and then run prep node. It checks the prerequisites. It looks for ports. It looks for existing installations of Platform 9. If you're using our old CLI, it will remove it. Checks the resources on the node as well. So that's one way to get going. The next piece that's sort of adjacent to that are our APIs. Our primary API is what we call KubeBert, and you'll see that in a lot of the requests that go out from the product itself. So on this KubeBert API page, you'll see examples of how to use it. There's a full reference here that you can open up and dive into to see, all of the API commands that are available. I also provide an example here. One piece that you will need to read and sort of understand a bit of is obviously the authentication portion of this. So one way to get in there and get started is to come to the Keystone Identity API. We started off in the world of OpenStack, and we started off with a platform that SaaSified OpenStack, so you can run OpenStack anywhere, and the OpenStack control plane is our cloud and our SaaS platform. When we built Kubernetes, we reused the Keystone Identity piece of that, which means to use our APIs, you're going to have to set up an OpenStack environment on your local desktop, and that is not as scary as it seems. This page will take you through that end to end, and what that will do is allow you to set up authentication on your client, and then leverage the Kubernetes API to start interacting with Platform 9. We also have a Terraform provider that you can use across AWS and Azure as well. And there's also our Kubernetes, what I call the K8s API proxy. This enables you, once you have an authentication token, to query against basically anything in the Kubernetes cluster using the Kubernetes API. So there's some examples on here on how you can run pods. This one is looking at our Platform 9 monitoring one, and then it will actually return the information about that pod. So just an example of using our SaaS management plane and authentication to proxy request to the Kubernetes API server. So there's some ways to get started with APIs and automation. All right. Where's next? CLI. Jing Swen?
The next one is around database.
Yeah, do you wanna jump on that?
Yeah, sure. So again, a good question. When you're deploying a database such as MySQL, whether you should deploy it as a stateful set or whether you want to deploy it as a deployment. So stateful sets and deployments are two constructs that Kubernetes provide to run your application pod. And if you are deploying something as a deployment, you can talk to the pod or the container or the service running inside it, either directly using the pod IP address. But pod IP addresses are very ephemeral in nature. So as soon as the pod crashes or moves to another node, the IP changes. So if you want a consistent communication between the database and your application, and if your database is running as a deployment, you expose your deployment, the database deployment, behind a service. And that way you can keep the configuration of the database name, the host name of the database, constant in your application configuration. And regardless of whether the pod exits and comes up on another node, you are still able to talk to the database without any issues. In case of stateful set, you do not need to expose the pod behind a service. And there is one certainty in stateful set that it creates the pod based on the number of replicas. So let's say your pod name is, let's say MySQL, and you have 3 replicas, then it will bring up 3 MySQL pods named as MySQL 1, MySQL 2, MySQL 3. And that way you have control over the name, the host name of the databases to which you'll be connecting. So you can directly connect to the database by saying the connection string being MySQL 1 colon 3306, MySQL 2 colon 3306, and so on and so forth. So in case of stateful set, you do not need to expose it behind a service internally, and your applications can talk to the database application just using that fixed name. Whereas in case of deployment, if you want to talk to the pods with their names, the names are randomly generated. So that's not a very reliable way of communicating in deployment. So depending on what kind of communication you have with your database, you can decide whether you should be using a stateful set or a stateless deployment. And again, depending on the kind of database that you are using, where the members of the database cluster need to register with a certain host name or a certain name, and you want that name to be consistent across pod reboots, you should go with stateful set, because whenever a pod goes down in stateful set, a new pod is created in its place with the same name. So when that new pod tries to join the cluster, it joins under the same name, and there are no surprises there. There is no new node popping up in that cluster. So depending on the kind of database, some would prefer to deploy it as stateful set. Some would prefer to deploy it as deployment. So it is a mixture of both, depending on your use case or the use case of the database provider. Uh, both these parties have option to decide on whether to use stateful set or deployment. If your database provider says that you have to use stateful set, then you have to use it. You should not be using a deployment, because they have handled some reboots across pods in a graceful way in stateful set as compared to a deployment. So hopefully that answers the question.
How does that change when you bring storage into the design?
So if we bring storage into the design, so if you want storage for your deployment, you need to explicitly specify that you want persistent volume, and for that precise reason, you need to perform kubectl create PVC, and the details around the volume, like what should be the size of the volume, the kind of volume, whether it should be block storage or something else. And if it is a stateful set, then the volume configuration can be part of the stateful set deployment, stateful set YAML spec itself. You do not need to additionally call PVC create. The stateful set, whenever it is getting created, the volume will be created internally. So a PVC will be created automatically for that stateful set. And as soon as that volume is created and it is mounted on the correct node, the stateful set pods just uses that volume and boots up. So in case of deployment, you need to explicitly specify the PVC. In case of stateful set, it can be part of the stateful set deployment spec.
You can also use a CSI, a storage class definition as well, right?
Correct. So you can specify that. If you do not specify the storage class, then it will pick up the default one. And if you do not specify a default one, then that volume, the PVC, goes into pending state because it does not know which storage provisioner to talk to. So usually it's a good practice to have a storage provisioner, a default storage provisioner, so that by accident, if you forget to specify the storage class, your application does not get stuck. It still gets a volume provision for it with the help of the default CSI plugin.
Yeah, let me see if I can pull up an example here quick, so people aren't thinking these guys are talking about things that seem far too difficult to grasp. Let me see. Have I got an example? This is Kibana values.yaml file. So this is actually a Helm app. If you're not familiar with Helm, they come with a pre-configured YAML file that provides a lot of specifications for how it's configured. Some of these will be using storage, so it's advised to always have some form of storage class in your clusters. So hopefully, no, I guess wrong. Let me find one. Elastic. Here, volume claim template. So storage class name. So I built this one on, I wonder if I should zoom in here. Is that even possible? I actually built a cluster running Rook Ceph, and then I deployed Elastic. We've got a blog that has that documented end to end. And it uses a storage class name, and what Raghu was just mentioning is, if this isn't provided, what will happen is it will actually just use the default storage class. So I guess that's one of the alternative ways from providing a volume directly is to leverage a storage class within the cluster as well, and it can provision it all dynamically. Hopefully that helped answer the question that was asked there around stateful or stateless, but with the mounted volume. Raghu, I mean, specifically, if someone's using a stateless application and a persistent volume, do you think that's going to, I guess, impact the architecture of that database example, or are you saying let's make sure we're following the instructions of the vendor of that database?
I think we have to follow the instruction of the database vendor. So, I mean, if they have specifically designed the pods to run on a specific node, and if the volume is available locally, then it's great. But if they have designed the database application to be resilient enough to be failed over to some other node, then we need the underlying storage provisioner that supports that, which can quickly unmount the volume from one node and quickly mount it to the other one where the failed over pod is going to run. So there are certain requirements that these database providers have on their own. There are certain database providers who do very frequent read and writes, and they would prefer a storage class with SSD as a backing hardware as compared to normal disks. So yeah, it can vary. For databases which do not do that many frequent writes, or for key value stores which prefer to write in memory, they do not have any storage related requirements. But database applications in general would prefer to have a distributed storage, which can be available on all the nodes and should be fast enough to respond to the IOPS happening every second, because they are not only doing the read and writes, they are also synchronizing among themselves and replicating the data and state across the entire cluster.
Yeah, that's important. I mean, there's plenty of storage options out there. You know, we have examples with Rook. OpenEBS is another one that's open source. One of our partners, Portworx, have a great platform as well. If you want enterprise, an enterprise product that you can get support for, they have a free platform that supports, I believe, 5 terabytes of data. You actually see I've got the two clusters I have running in my environment today are both built on basically a hyper-converged stack, and have Portworx running within them, and they keep the block devices synchronized across all the nodes. The same as Rook and Ceph, the same as OpenEBS. Obviously, the faster the drive supporting your either virtual or physical nodes, the more stable, resilient, and up-to-date that storage infrastructure will be, and the faster your applications are going to be able to read, write, and respond to the application and user requests. Getting started, if I was to put my hat on and say I'm just learning Kubernetes, what's the easiest way with storage? If you've got multiple nodes or the ability to do multiple nodes, I would definitely say one of Rook, Ceph, OpenEBS, or Portworx. All of these, all they require you to do is build your node, have a volume mounted that's obviously running the operating system, and then have a mounted unformatted volume also in that VM. So for all of the VMs we build, we base them on OpenStack. I just build a node, and then I attach another 20 gig drive, for example, across the worker nodes. And then I personally use Portworx, so I find it really easy to get up and running. Our doc site has instructions. It's free. So that's a great way to get started. And just like us, they run ask us anything sessions, so you can get in there and ask questions and get started. Rook is also another great one. Same thing, just need unformatted mounted volumes on the OS, and Rook will take care of building a distributed Ceph cluster on top of those as well. Scrolling down, someone wants to live chat. Ranesh, should we give this a go? Ask to unmute. Let's see if this works. We've never done this before.
It seems to be working. This is excellent. I thought like webinar was just a one-way street. But this is excellent. Yeah, I'll actually give a little bit of background to get the context. I mean, so I understand like deployment and stateful sets and everything that goes behind. And there are two other constructs that I'm trying to get get a handle on. One specifically is the operators. The second one is the admission controllers. I know initially you touched upon the operators. If you were to just like start from maybe from a basic standpoint itself, right? If you're running like a deployment, stateful sets, and some services on top of it, how would you explain operators, and why would an organization or anybody for that matter need operators?
Chris, should I take that?
Go for it.
All right. So yeah, again, a very good question. Like, I mean, the sole and primary purposes of operator is to not only manage the life cycle of your applications that you are running as stateful set or deployments, but its purpose is to ease the process of deploying the applications as well. So let's say if you want to deploy a WordPress application, where you have a WordPress front end and then you have a MySQL database behind the scene. So if you want to run this application, you'll first have to configure the MySQL database. And that means running a MySQL deployment, providing an underlying PVC storage, and then exposing MySQL behind a service. So these are three constructs behind the scene that you have to create. Then you move to front end, where you have a WordPress deployment. And the WordPress deployment needs to know where the database is running, what is the database username and password. And once you have all of that, you will construct the WordPress deployment YAML with the values. And then you will apply that template. So it will create a deployment for you. And even after that, someone from the outside cannot access the application. So you'll have to create a load balancer type service, which actually exposes the WordPress behind the scenes. And that way, you can expose the entire WordPress application to someone who wants to manage their web pages using WordPress. So this involved a number of multiple steps where you had to use 3 templates for MySQL, 1 template for WordPress, and then 1 template for load balancer. Now, if you had an operator, with the help of operator, what you can do is you can create custom resources. So just like there are API resources called pods, deployments, service, in the same way, you can define your own custom resource. And here you can decide that, let's say my custom resource is called WordPress app. Once you have that, you can decide the way in which you can deploy this application. So your operator will have the inbuilt logic of deploying all these templates behind the scene. And you will not have to manually intervene and configure each of these services separately. Now you'll only have to say in a YAML template that create an object of type WordPress app, and I want it to be exposed behind this load balancer, right? So
Okay.
you just have to apply that one template, and the operator picks that up based on the event notification on that custom resource definition. And then it internally creates all those services for you behind the scene. So now what you can do is you can create multiple such WordPress apps with just a single YAML template, and you do not have to manually configure MySQL WordPress front end for, let's say, hundreds of instances that you want to create for WordPress app. So it not only manages the life cycle, like monitoring and unblocking the application if it is in faulty state, but it also eases the process of deploying the application for you. And if you want to get started, there is a very good operator framework library, which has a very big community backing. And with the help of it, you can quickly start writing operators for your custom applications.
Okay, so I mean, so basically, it's more of a wrapper that you can put together where you bring in secrets, config maps, deployments, all those things you can bundle together, so that once anybody wants to do that, they would apply operator by a simple YAML file.
Correct. That is correct.
Okay, and you can pass like different arguments, different parameters. Like say you want to configure a particular database, but you want to randomize the password, or you want to pass it your own value. Does it support?
Yeah, it does that. So when you provide the definition of your custom resource in the Golang code, you can specify what are the fields which you want to configure and what kind of values it will expect. And you can have as many fields as you like. You can have the level of nesting that you would want to configure as per your requirement. And Kubernetes is just going to be agnostic to all of this because you are bringing the definition of the custom resource from your side. So uh, in Golang code, you specifically decide the kind of field that you would like and the kind of value it encapsulates. So you have freedom to add any of the accepted values there. It can be a string, it can be a boolean, it can be an integer. So it is up to you to decide what you want to use in the field.
Okay. And is operator a Kubernetes construct? Is it a different construct that sits besides or on top of Kubernetes?
So from Kubernetes perspective, an operator is just another pod, right? It is just another deployment that is running on the Kubernetes cluster.
Got
So
it.
Kubernetes will manage it just like any other pod.
Or is it just like another CRT that you're creating, right?
Yeah. So
Okay.
the operator is just a deployment, and if you create a CRD, then the operator picks up the request to perform the required operation for creating that custom resource CRD.
Okay.
Yeah.
And just one final question: how does it? I mean, like even Helm charts are like pretty much the same thing, right? You can bundle everything together, and once you deploy a Helm chart, it pretty much does the same thing. So how is operator different than Helm charts?
So with Helm charts, you can perform the application installment, but the lifecycle management of the application is not possible with Helm because Helm does not have a service running on the cluster which monitors all the deployments and pods that you have created. So with Helm, you can only upgrade the pods. You can only install and perform an install operation. But if you want to manage the lifecycle, then you need operator.
Oh, okay. This is really good. Thank you so much for this.
Yeah, these are
Thank you.
great questions so far. So our monitoring deployment, for example, if I choose this and say monitoring and click disable, that's actually going to, from our SaaS management plane, go to that cluster and remove our monitoring, which is an operator. Now that's turning it off completely. That's one click. If I have monitoring enabled and I go in there and let's say I want to add persistent storage to that monitoring deployment, I can edit that. I could edit that live and add a storage class, and it's automatically going to restart that pod with that storage class in use, right? Because of the life cycle management in there. Does that make sense?
Yeah. And just a question that just came. Just like you have Hub and other like repositories that you have, and you have a registry for Helm charts. Is there any concept of a operator registry?
You mean people that have built them for their open source products?
Yeah.
That's a good question. Generally, I found them sort of application by application. So if I'm looking at ingress controllers, does it have an operator and a way to deploy it in that method? So not that I'm aware of. Raghu?
Yeah, so I guess there is an operator framework supported by, I think, OpenShift, which has a library of all the operators, which multiple application vendors publish their application specific operators there. And people can install those operators by first installing the OpenShift's operator hub pods inside the cluster. And once that operator hub pod is running there, then they can deploy operators of all these applications that we are seeing here right now.
Thank you,
So
Cody.
it is, yep. So it's like an operator that deploys operator of other services. So any application developer can publish their operator related information here. And if someone wants to use that, they can use operator hub to deploy that operator.
Oh, okay, got it. So just like you have Helm command line that you need to deploy Helm charts, you have to have operator pod itself, which can deploy other new operators.
Yeah, it's something
Okay.
like that.
Yeah.
Awesome. Great
I'm
answer.
going to hand the ball over to Peter Trise. I believe I can say, ask to unmute.
Yeah. Operator hub is the place where you put these things. And therefore, there are different qualities for operators. And you need to understand of how you're going to support it. Let's say you're writing your own operator. When you think about this, are you going to support this for all your customers as an example and say that you're going to create this as a self-healing piece of software? Even the way you described it, that you had a whole host of services that are being orchestrated into something. This is where operators need to be understood as to what quality that you're delivering to each one of these systems. Is it base install? Is it full cycle full? Is it on autopilot? You know, these are the types of things that you need to understand.
That's a good point. So it's not fire and forget. You can't just grab an operator and think, if something goes wrong with one of these pods, it's going to be resilient.
Well, it's what did you get? What is the quality of the operator that you actually installed? That's the first thing you need to understand. And most of the operators they're totally documented for what it is that they have. Like it's just like a base install, and therefore it's packaged up, and therefore you deliver it. And by the way, you only need a Kubernetes. It's not like restricted to OpenShift. You can pull it down and stick it on any Kubernetes cluster. Let's put it that way. And therefore, these things are like packaged up solutions for certain aspects, like you want to create a CI/CD, therefore you can install Argo, or you want to put on, Kafka onto your system, or you want to put a full-blown database. But each one of these things, when you think about it, the topic that you're talking about today is about storage. Most of these solutions, most of them, if not all, are going to use some amount of storage behind them, because the fact that they're going to change, because you're going to modify them and you're going to put state inside of them.
That's a good point. This is actually really helpful information. So there's the capability level, which is what you're mentioning here, right?
Oh, yes.
So
there are different levels of capability for each one of these things. And that's why operatorhub.io, someone else put it in the chat and he was very correct. And this is a place where it's a marketplace for like installing things. And therefore there's different, even some of these things I think are licensed too.
Yeah. I mean, something like Dell has a CSI operator there. It's a very smart way to orchestrate storage for resiliency. This is Elastic, so open source, depending how you're using it. You can hear it does full life cycle, seamless upgrades, and the install. This is a great resource.
Does it also support network policies? Can you actually do security?
Inside of the operator itself?
Yeah, I mean, like if say I only want to allow like certain kind of traffic between the pods within that operator framework. I mean, like, does it come bundled with like a security built into that one, like a network policy or something? And if I'm writing my own operator for say one of the applications that I'm working on, can I embed like network policies into the mix?
That was one of the questions that I had for the people on this panel. Can we install something like Istio or Envoy into these Kubernetes clusters? Because these are the very things that are going to give you filters, if not restrictors, for how you're going to control like SSL security policies, or the fact like you want to only restrict certain network traffic to my database. Therefore, pod A and pod B are the only ones that can talk to the database, and therefore it is restricted by network policy in Istio to not allow any other traffic going to it.
Yeah, that's a great question. So we currently don't have any service meshes supported out of the box. There's some instructions on a GitHub repository that we maintain called Core Kubernetes with a K.
But if you allow the CLI to operate, therefore I might be able to access the CTL, and therefore I could install it myself onto my own cluster. Is that possible?
Correct. Yeah. So, we're a bring your own infrastructure. So I'm running on what we call Bare OS. So that's any Ubuntu or CentOS VM, right? Or physical server,
That's fine.
or Azure or AWS. So if I was to download a kubeconfig and run kubectl, actually, I could probably do this now. I believe I'm on the VPN. Kubectl get nodes. I'm connected to one of these clusters. It's going to connect to it just like, oh, I am unauthorized. All right, my kubeconfig is not up to date. Yeah.
I like that. No, good way to show you're not authorized. I like this first.
Yeah, it's good, right? I was playing around with my kubeconfig and changing context, so I'm not going to attempt to resurrect that right now live. So you can do whatever you want to the clusters, right? We manage all of the life cycle and upgrades and keeping it running, and deploying things like monitoring and keeping that running. So you can just come in and click Grafana and you'll get access to that data, right? Based on the operator framework. That's what's keeping this running. In terms of doing security policies, so we support 2 CNIs. Our preferred CNI network plugin is Calico. One of the strengths of using Calico is it has a security policy framework, right? So immediately you can start leveraging Calico to improve the security of your underlying cluster and how those nodes and pods are talking to each other, right? In our next release in 5.1 that's coming out with Kubernetes 119, we're upgrading Calico to its latest release, which also brings in the ability to use WireGuard, which will give you node-to-node encryption as well, which is a great sort of security and enterprise level feature of the Calico CNI. When you move into the service mesh layer, that's when you're really doing application level security constructs, right? Something's leveraging the service mesh, it's controlling what's going on in terms of what traffic, type of traffic, and the pod-to-pod communications. So that is another great way to secure your Kubernetes cluster and your applications as well. Does that help?
Yes, it does. But most of the time when I'm thinking about this, I want to be as most interoperable against other Kubernetes clusters of like the same thoughts like people are using like Istio and Envoy to handle these things. And therefore, we're even thinking about going outside of even like OpenShift as a provider of a Kubernetes. And therefore, we're going to stick our own OpenID provider inside of our own system so that when we package up our software, the authorization as well as the SSL management, as well as all this stuff then turns into our idea of like an operator delivery of something that we put inside of Helm and then deliver it to our customers. But these are the things that why we want to use Istio and Envoy and Keycloak and things like this is to create our own security island within another provider.
Yeah. And so we've got a partner called LucidWorks, and we're supplying the Kubernetes infrastructure and operating that for their customers, right? For exactly that purpose. They don't want their users to have to worry about running Kubernetes and worrying about the cluster being available, right? So they partner with us. We handle that for them, and their users just get to consume their app, and they're packaging their app as a completely self-contained mechanism using exactly the constructs that you just described.
Do you have any protection for what I want to say bad customers? I mean, I'll talk about I'll use the word threats. Like when we think about controlling our software and the fact that things get out of control, like SolarWinds and what happened with the Orion software, do you have ways of detecting things are kind of like running awry with someone's deployment?
So our SaaS management plane, so I'm on one here, right? This is running in our free tier. An adjacent one is completely isolated in every single way, shape, and form. So it's they're separate deployments, and it's on your infrastructure. So you don't have to worry about anything that one deployment is doing impacting your deployment. And we don't touch the application data, right? We're bringing back cluster metadata and operational principles. So they're isolated, and what I'm doing is never going to impact what anyone else in the free tier is doing or our enterprise environment either. Yeah. I'm going to jump onto another question about host path. We talked a lot about providing host path out of the box without deployments. One of the issues that you'll run into with it is it's node specific. So it's going to work in some circumstances, but in others it's not going to be great, and it's not really going to provide much value from a production perspective. So I guess if you're just doing like a single node cluster and you're trying things out and you're trying to learn, it will help there. So that's one of the spots that we've looked at providing it. But we thought it would be a better investment of our times to really focus on simplifying Rook for people. Putting up blogs and creating a repository for that. Working with companies like Portworx that provide great production ready products, and also have a free forever entry point as well, so you can get going, and then when you're ready you can just easily evolve your deployment. OpenEBS and Maya Data as another example of that. They're also a partner of ours, so you can start with them, right? Completely free, completely open source, and then when you're ready to move to production and you want support for that data and you're worried about data loss and stuff like that, move on to that. What's next? Michael, what's the next question that's come in? Is there anything in Slack as well?
Yeah, I think we've got to most of the good questions here. We are going to wrap soon here. If we didn't get to your question, we will definitely follow up. As a reminder, you guys can also add the AMA channel, and we'll be able to answer your questions in real time offline from this session.
Yeah. I'm just looking through the Zoom chat to see if there's anything that has come up that has not been answered. It was good that we got people talking live. That's awesome. I think we touched on everything. I guess next time we might run a poll. One of the two pieces we're looking at doing next is building in something like OpenEBS or Rook or even Portworx. But we're also looking at bringing in an ingress controller. So
on that point, in the follow-up, we will be sending a poll just to kind of gauge, topics of interest for our attendees. And we'd really love your input, so we could plan our next session and keep our content engaging.
Yeah, hopefully this helped answer some questions for people. If you're looking to get storage up and running, we do have blogs on Rook on our docs site. If you come into storage, you'll see an end-to-end on Portworx. I understand that some people might want to stay open source. In that case, I'd say go to Rook. Once again, the great thing about Portworx is there is a vendor behind it, so you will be getting a lot more responsive help from that vendor as well. So super easy to get up and running, and the two platforms work well together. I've set up their backup platform. I've put Mini.io for S3 storage into clusters. So I think this is a really great platform to get started with. I found it personally slightly easier to get up and running than Rook in a cluster as well. Cool.
Folks, if you'd like to continue to engage with our experts, please feel free to join our Slack instance if you haven't already. That's where the AMA channel that Michael's alluded to will be available. That's slack.platform9.io. You can also engage with us on our discourse at community.platform9.com.
Cool. All right. Shall we wrap it up?
Yes. All right. Thank you, everyone, for attending. Thank you, hosts. And we'll be sending a follow-up with the recording here. So look forward to talking with everyone soon.
There'll be another one in 2 weeks, right?
Yep, 2 weeks.
All right, and we have a release coming out super soon, so stay tuned. Right,
Right, everyone.
have a great weekend, everyone.
Bye-bye.
Thank you.
Thank you.